Basically, when I teach pre-calculus, I teach my students that we can, in pre-calculus, look at only 3 different types. Type 1, I'm hungry. Type 1, same degree over same degree. Type 2, degree n and degree higher than n in the denominator. Type 3 is degree n, and this one is exactly n plus 1. Do we have more than 3 types of rational functions? Yes. But everything else is way more complicated. And they will not have horizontal or slant. Okay. All 3 can have vertical. This one has y equals leading coefficient over leading coefficient as the horizontal asymptote. This one is always 0. The horizontal asymptote is always 0. And this one is the only one with a slant asymptote. The only one. Like degree 3 over degree 2. Degree 9 over degree 8. Degree 7 over degree 6. Only by 1 unit higher at the top. So degree 3, degree 4. Degree 7, degree 8. It's the only one with a slant asymptote. Higher degree at the top by 1 unit higher. So we graphed one like this. This is even easier than that. You will see the horizontal asymptote is 0. Now I would like to address this one. And let me pick a function. Did I start that? Yes, I did. So here it is. What is the degree at the top? What is the degree in the denominator? It's the only one that would not have a horizontal, but it would have a slant. What does that mean? It means that the end behavior will not be a number. But what? Negative infinity to infinity, or? That's the only thing, right? So it's not going to be a number. The limits will not be 5 and 5. But they will be either negative infinity to positive infinity or positive infinity to negative infinity. The function must follow that asymptote, like it did follow y equals 2 in the previous example. It must follow whatever. Okay, that's the only difference. So I'm going to factor the top. And then, of course, we're going to start with what? We always do that. We're asked to graph. So what is our starting point? For sure. The domain. Very good. Negative infinity, negative 1, 0, infinity. Since x plus 1 does not go away, x equals negative 1 must be a VA. Can anyone give us the x-intercepts? Excellent. Please make sure you put them correctly in the table. Can anyone give us the y-intercept? Here's how we determine the y-intercept. How much? Very good. Excellent. Now I need 4 limits. And we're done. with the function, right? I need this limit, I need this limit, I need this limit, and I need this limit. Good. So let's start with the limit as x approaches negative infinity. Limit x approaches negative infinity from x squared minus 4 over x plus 1. Please plug it in and tell me the type of limit. Because I consider myself lucky if it's 0 over 0 or infinity over infinity. Where does the top go? Excellent. Where does the denominator go? Doesn't matter. Sign is not important. So then what do I do? Good. Top is? Excellent. The bottom is? Good. The limit is? When x approaches. That's it. At the other end, limit as x approaches infinity from x squared minus 4 over x plus 1. Again, infinity over infinity. The top goes to 2x over 1. So the limit is? Excellent. I need these two. So limit as x approaches negative 1 from x squared minus 4 divided by x plus 1. From the left, I said left, right? So of course I had to put plus. Sorry about that. And x squared minus 4. So this one is from the left. Of course that is from the right. Good. The top is definitely what type of number when x approaches negative 1. Wait. Sorry. Negative 1. When x approaches negative 1, the top goes where? We have negative 1 squared minus 4. Of course, negative. Very good. Awesome. So the top goes to negative. But now negative 1 from the right, negative 1 from the right means negative 0.9. So negative 0.9 is positive, so the answer would be? Very good, awesome. And now negative 1.1, negative, so then the answer is? Good. So negative 1 from the left is positive infinity, and negative 1 from the right is negative infinity. This is it. I can't determine anything else. We're done about the function. From the function itself, this is it. What is my next step? F prime indeed. So let's find F prime. And you can say, but what is the slant asymptote? In a minute. So where am I? 12, 13, 14. So y prime. The top prime. 2x times the denominator times x plus 1 minus x squared minus 4 in parentheses times the denominator prime, so this is x plus 1 squared. Please be very careful. It would be a terrible mistake again and again. I'm saying that to simplify that x plus 1 from the top with an x plus 1 from the top, because x plus 1 at the top is not a factor. It's part of a term. Okay, so then I have 2x squared plus 2x minus x squared and plus 4 over x plus 1 squared. And this is extremely ugly. So it's x squared plus 2x plus 4 divided by x plus 1 squared. However, I like it because the numerator doesn't have real solutions. Negative b plus or minus the square of b squared which is 4 minus 4ac. I like it. It's always positive. This is always positive. This is always positive. Let me show you why. So x squared plus 2x plus 4 equals 0. X equals negative b plus or minus b squared minus 4ac divided by 2a. So these are not real. And since the leading coefficient is positive, it opens upward, and it will not touch the x-axis. So this is always positive. This is always positive. I like that, which means what? No critical numbers, so no max min. No critical numbers, no max min. And the first derivative is always positive, which means the function is always increasing. I have an error somewhere. It doesn't make any sense. So let's see what I did. So it is 2x. And it is x plus 1. And it is, yes, that's correct, that's correct. So what did I do? So it is 2x squared. It is 2x. It is x squared. And it is plus 4. And it is x squared. And it is plus 2x. And it is plus 4. But something is wrong. Because from negative infinity to 0, the function is increasing. And from 0, oh yeah, okay. Yeah, for some reason I thought it was something wrong and it's also decreasing. But let me check. Okay, I'm on the right track. I just thought that I messed up something, but it appears that I didn't. Okay, I'm happy. So from negative infinity to 0, yes, it's increasing. From 0 to infinity, yes, it's increasing. From negative infinity to negative 4, yes. From negative 4 to 0, yes. And from 0 to infinity, yes. Yes, for some reason I thought that it was something that I missed, but apparently not. Okay, before we continue with the second derivative, which is not friendly at all, I would like to talk about this slant asymptote. So the function is x squared minus 4 divided by x plus 1. We have to use long division to determine the quotient. The quotient is the slant asymptote. And you'll understand in a minute why. Only the quotient. There will be a remainder, and you'll tell me in a minute. I'll ask you, and you'll tell me why only the quotient is the slant asymptote. So we have to divide. So when we divide x squared minus 4, the middle term is missing. So I divide by x plus 1. So I left some space in case I need it. If I don't need it, it's not going to hurt. If I need it, it has to be there. Okay, so x times what is x squared? X. So we have to go back and distribute, change the sign, and write underneath like terms. So x times x is x squared. Remember, we have to subtract. X times 1 is x, and we have to subtract. These two go away. And then I have negative x minus 4. Final question. X times what is negative x? Negative 1 indeed. Negative 1 times x is negative x. I change the sign. And negative 1 times 1 is negative 1, and I change the sign. What is the remainder that I have to box in? Yes, it's negative 3. So this function f of x equals x squared minus 4 divided by x plus 1, or this function are identical. Would you agree? So x squared minus 4 divided by x plus 1, or the quotient of x minus 1 minus the remainder over the divisor, are identical functions. So now, when x approaches infinity, where where does this go when x approaches infinity? Or negative infinity, doesn't matter. Where does this go? Right. That's the reason why that is a slant asymptote. So y equals x minus 1 slant asymptote. Okay, finally, we want to be able to fill this in. So we're going to find the second derivative. I wasn't looking forward to that, but let's do it. So the first derivative is x squared plus 2x plus 4 divided by x plus 1 squared. Let's see what we come up with. I know when I see you're tired, just give me a couple of minutes to finish this and graph the function. Okay? The top function prime. So this is one other reason why I want the second derivative to be the last in the table. Remember a few minutes ago we worked for about 10 minutes on it? It was, yeah. So sometimes we may be able to figure out the rest without finding the second derivative. But now let's find this one. So you already at 2x plus 2 times x plus 1 squared minus x squared plus 2x plus 4 times 2 times x plus 1. Luckily for me, I always run out of room, as you know. But the inner function prime is 1. That's the reason why on test 2, I kindly asked you to simplify this fully by factoring. Because this is a lot of work if I don't simplify it. And I have to multiply a lot. But I see that the terms at the top have a common factor. And that common factor has to be pulled out. Which common factor am I talking about? Right. So once I pull out an x plus 1, an x plus 1 in the denominator, then I can do this. But not in this step, in this stage. I have to factor out x plus 1. So what is left at the top? So I have, let's write it first. I have a 2x plus 2 to be multiplied by an x plus 1. And then I have a negative 2x squared and minus 4x and minus 8. Because I have this 2 that I have to distribute. Negative 2x squared minus 4x minus 8. And I have to multiply those two. So therefore, when I multiply, this is x plus 1 times x plus 1 with a 2 in front. So it's going to be 2x squared plus 4x plus 2 minus 2x squared minus 4x minus 8. I am really happy, right? Because this is negative 6 over x plus 1 cubed. So this will never be 0 because the numerator can never be 0. And you cannot assume, remember, be very careful when you study the sign. So I would like you to think in terms of this. This is only for the purpose of studying the sign. Everything is important in the function. But for studying the sign, I don't need to worry about this. So negative 1 times x, and negative 1 times negative 1 times positive 1. So it's negative x plus 1 from positive to negative. And crossing at negative 1. So at negative 1, it's coming from positive and negative. And you know it's very easy to catch our mistakes if something doesn't match the other rows, then I know, oops, something is wrong. So on the table, the only thing that I have to add was y equals x minus 1 slant asymptote, because I'm using just my table when I'm ready to graph, and I have to graph the asymptotes first. So we will graph a vertical asymptote, which is x equals negative 1. We will graph the slant asymptote, which is x minus 1, and then the rest. Ready? Oh, I thought I skipped 14, but no, I didn't. There was a page on the side. Okay. Ready? So first, x equals -1. And now I have to graph y equals x minus 1. When x is 0, how much is y? Excellent. When y is 0, how much is x? Very good, 1. Y equals x minus 1 is the slant asymptote. So this is what I have to do first. Graph both asymptotes. One is a vertical, x equals -1, and the other one is a slant, which is x minus 1. Now I go back to my table, and I see -2, 0. I see 0, -4, and I see 2, 0. Ready? So -2, 0. I see 0, -4. 1, 2, 3, 4. And I see 2, 0. Perfect. Now, it's coming from -infinity, opening upward, crossing at -2, 0, going to infinity on the left-hand side of -1. Coming from -infinity, opening up, increasing, crossing at -2, 0, going to infinity. And this has to be closer and closer to the slant asymptote. Okay, it's coming from -infinity on the right-hand side of the vertical asymptote, crossing at -0, -4, crossing at 2, 0, going towards infinity. Allow me to extend the vertical asymptote. And this is the function x squared minus 4 over x plus 1. Yes, we can put in quickly in the graphing calculator. Last thing, and I'll stop. So please do not forget, rational functions require parentheses around the top, x squared minus 4, close the parenthesis, and x plus 1. The calculator is not as smart as you are. Don't forget parentheses, and I just, for some reason, you didn't take it. I didn't need that. X plus 1. The calculator does not know as much as you do, so you have to put in a second function as x minus 1, which is the slant asymptote. And then I'm going to use, let's say, zoom 6. Here it comes. Here it comes, and now the slant asymptote. Any questions?